right, here is the other review day quiz. This is focused more on exponential functions rather than focusing on exponential properties. So we're looking for exponential growth right here. And we've looked at a lot of equations that look like b times m raised to the x. And if we're looking at growth, that means that our multiplier has to be bigger than 1. So I'm going to start by just looking for which ones have multipliers that are bigger than 1. So this one has a multiplier of 3. This one has a multiplier of 1/2. That's smaller than 1. This one is 5 over 4. That's bigger than 1. This one is 0.98. That's smaller than 1. Now the tricky thing is it says there's only one answer. So I need to look a little closer. The b value does not matter as far as determining growth or decay. So the only difference I'm noticing, and it's kind of tricky to see, is that the first option has a negative exponent and the third option has a positive exponent on it. If you remember, we've talked about several times that a negative exponent means you're dividing by the base. And so option 1 has a multiplier that's bigger than 1. The multiplier for option 1 is 3. But it has a negative exponent, so it doesn't count as growth. It's actually telling us to divide by 3. So option 3 is the correct option for exponential growth. Exponential decay, same sort of idea when we're looking at b times m to the x, except for decay, we're looking for our m to be less than 1. And that actually just kind of pops out. Nothing tricky about this one. Option 1 has a multiplier that's less than 1. Oh, I guess I spoke too soon. Option 3 also has a multiplier that's less than 1, but it has a negative exponent. And so dividing by a fraction actually works as exponential growth. So option 1 is the correct answer. Okay, what about here? Exponential growth. And these all have negative exponents. And this is a little bit tricky because they all have negative exponents. But you'll notice that option 4 is the only one that has an m value that's less than 1. And if your m value is less than 1, but you have a negative exponent, then that actually means that you are growing. Think about dividing by 1/4. If you start with something and you cut it up into fourths, you actually have a bigger number of slices than you started with. So when you're dividing something by a fourth, you're going to get a bigger answer because you're asking how many 1/4 fit into my original number. So dividing by 1/4 gives me bigger answers, whereas all of the other ones, if I divided by 5/4, or if I divided by 2.8, or if I divided by 1.5, I would get smaller and smaller and smaller answers, which would be exponential decay. That's a little bit of a tricky one. Here we have an exponential function and we want to find f of 10. So I notice that the b value is 1 because that's where x equals 0. And I notice that the m value is 3 because each y value is 3 times the previous y value. So I know that we have an equation that's 1 times 3 raised to the x. And I am asked about doing f of 10. So f of 10 means you do 1 times 3 to the 10. So you can just grab your calculator and go 1 times 3 raised to the 10. Should look just like that at the bottom. And it gives me the answer. 1 times 3 to the 10 turns out to be 59,049. Pretty big. Exponential growth. It's pretty big. Okay, same sort of idea here. When I look at these numbers here, my b value is pretty obvious. It's just this big number, 65536. My m value is not obvious. So what I'm going to do is just take my y value, my second y value, and divide by my first y value. Remember, why does that make sense? The whole idea is that you take your first y value and you multiply by m to get your second y value. And that means that your m is just, you can solve that equation. We've solved tons of those sorts of equations this year. Your m is always the second y value divided by the y-intercept. Okay? And so if I type in 16384 divided by 65536, I get 0.25. And so I know my full function then is y equals, start with 65536, multiply by 0.25. Oops, I wrote a 4, it's a 5. And raise that to the x. For f of 8, I just replace the x with an 8. So 65536, 0.25 raised to the 8 gives me an answer of 1. And that just means if I continued this pattern a couple more times, I would get, for x equals 8, I would get y equals 1. All right, similar sort of thing here. This one's easier than the previous one, I think. The b value is 1 because that's the y value when x equals 0. The m value is 2 because each y value is twice as big as the previous one. So I write y equals 1 times 2 raised to the x and substitute x equals 9. 1, 2 raised to the 9 gives me 512. All right. Very similar sort of thing. You may not be able to see the m on this one very easily, so let's go over that process one more time. The b value is the y value that matches with x equals 0. The m value you can get by taking your second y value and dividing it by your first y value. This turns out to be 1/2. So our y equals negative 4096 times 1/2 to the x. Take 10 and throw it right in there for the 1/2. Negative 4096 times 1/2 raised to the 10, like that. And I get negative 4. There we go. Moving right along. Just a few more questions here. So an investment of 75,000 increases at a rate of 12.5% each year. Whenever I see a percent, I convert it to a decimal, 0.125. And whenever I see increases, I add that to 1. And so my m is going to be 1 plus 0.125, which is 1.125. We've talked about in this video a few times how growth always multiplies by a number bigger than 1. And so whenever I see the word increase, I know I'm going to multiply by a number bigger than 1. That's why I added 1 to the 0.125. That's why I added the 100% to the 12.5%. By the way, a lot of people chose this answer. This is wrong. This would be saying that you multiply your money by 12.5 each year. If you find that investment, please tell me and I will retire early, because multiplying your money by 12.5 each year, you don't need to work very much for that. The answer is C here because that has the correct multiplier. Now this one, we just figured out the equation was 75,000 times 1.125 raised to the x, and this one asks for the value after 30 years. So I just typed in the equation 75,000, 1.125 raised to the 30th, and it's a gigantic amount of money. The idea, again, is that exponential growth gets really big eventually. So that's the amount of money that you have. So it looks like just by sitting on it, your money becomes $256,000. That's not so bad. Okay, very similar idea here, except for it's a decrease. And we talked earlier about how decrease means you're multiplying by a number that is smaller than 1. So I take my percent and I change it to a decimal, 0.014. I need my answer to be smaller than 1. So I start with 1 and I subtract. And that means that I have 98.96 right there. That would add up to 100%. Did I do that right? No, I did not do that right. I had a little bug fly into the room. So 0.9896. Let me just double check that. I'm second guessing my decimal skills here. 0.986. Apologize. Literally was doing the video and a wasp flew in right in front of me and made me trip out for a second. So that's our M value is 0.986. Remember on the previous problem, I did 1 plus the interest rate. Now I do 1 minus the interest rate because it's decreasing here. All right, so we have 752,000 people and 0.986 remain every year. All right, hopefully no more wasps. To the nearest whole number, what will the population be after 18 years? So I type in 752,000, I go 0.986, and I raise that to the 18th. I get this number, see how I typed it in? And so that number, 583,448. Boom. Okay. House has been losing 2% of its value, so that means it's keeping 98% of its value. That's 100 minus 2%. So that's the one I want to use here, where it starts with 250,000 and it keeps 98%. That's the 1 minus 0.02 idea. Moving along, same idea here, 20 years after its initial purchase, we type in 250,000 times 0.98 raised to the 20th. This is super uncommon, by the way, especially where we live in Portland. Houses don't typically lose value. And so this, in Portland, houses gain something like 5, 10, or 15% value each year, depending on how the market's doing. So this would be a very um, maybe it's realistic in some other markets, but it's not realistic in Portland. All right, bacteria culture started with 200 is growing by 40% each day. So 40% becomes 0.4. And then I add that to 1 because it's growing. Growing by 40% means 140%. That's this first option right there. Now we want to know how much it will be after 10 days. So I go 1.4 raised to the 10th, 200 times 1.4 raised to the 10th. I hit enter and we get 5,785. That's a lot of 5,780. That's a lot of bacteria just after 10 days. And I believe this is the last one here. So like we've talked about several times now, if something is decreasing, it's less than 1. And so we know that your M is 1 minus the percent rate. So our 0.974 is 1 minus R. Okay, so we can just subtract 1 from 0.974, giving us negative 0.026. You might have been able to do that in your head. And then dividing by negative 1 tells us 0.026 is our R value. Multiply that number by 100 to change it into a percent, and your percent would be 2.6%. Only numerical values are accepted, so I would just type in 2% because the question asked me what percent. Another way to think of that is just to try to think, okay, 0.974 is 97.4%. So how much more do I need to add to get up to 100? To go from 97.4 up to 100 adds 2.6. So thanks for watching. Ask questions, comment if there's anything I said that was wrong or didn't make sense, and please let me know how else I can help you get ready for the test.